Hi folks, I'm going to help you set up in your packet number 8 and number 9 so you can figure out which ones are the series resistors, which ones are parallel. Make sure you get the right RAQ, and then from there kind of help you get everything organized so that you can get those problems done. Alright, so first thing, we find the battery, short side is negative, I run the current. I am going to use two different colors, so my first set of current, as it leaves the negative and moves back towards the positive side, it can either go up or down and over. So I'm going to send it up. That's route number 1. And then as I switch to another color, the other electrons that don't follow that route go up and over. Okay, so everything, all the current goes through resistor 1. It then splits. Some of the current goes through 2, some of it goes through 3, before it all comes back together and goes through resistor 4. We have 2 series resistors. Reminder, series means it gets all the current, this right here and this right here. All the current goes right here. It then all eventually comes back together in both colors, green and pink. Everything goes through resistor 4. All right, first thing we have to do, we have to find the REQ. Okay, you have to do your parallel first because they are 1 over. So our 1 over our REQ is equal to 1 over 200 plus 1 over 400. These were parallel, which means they have to go 1 over. Into your calculator, you're going to type in 1 divided by 200 plus 1 divided by 400. You're going to hit enter. When you get that answer right there, it's going to be a little decimal. That is not your REQ, that is 1 divided by. So your last step to that decimal, you take 1 divided by that decimal. Don't stop around. Use your second answer button so that it dumps it in. So you would take 1 divided by second answer. It'll dump in that whole decimal for you so you don't have to round and you won't be off in any way. Okay, so please pause the video, type it in for me so you know how to do it, and from there you should get 133.3. That is going to be the resistance of these 2 right here. That's not the full resistance. To the parallel guys, you have to add the 2 series ones normally. This is a series, so I'm going to add 200. It gets added in normally. This is a series, so I'm going to add in 100 as well. When I take the 133.3 plus 200 plus 100, I get a total resistance of 433.3 ohms. That is my total resistance. My next step, always, 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 you take delta V equals I times R, and you solve for the total current flowing through the system. Okay? Full voltage is the voltage of the battery. So delta V is going to be 40. I'm solving for I, and I just found my total resistance, 433.3. I need to divide under. I'm going to take 40 divided by 433.3. I am going to round it to 2 decimal places, and I got it to be 0.092 amps. Okay, once you have those 2 things done, what I do is I get everything situated. So under each resistor, I get my spot, I have a spot to find the current and the voltage for resistor 1. I'm going to do the same thing for resistor 2. I'm going to do resistor 3. And I'm just going to put them here. Okay, so I now have a place to work my way through. Okay, so I have to start with the series resistors. Series means it gets all the current. We just calculated that all the current is 0.092. So you look back at your 2 resistors, we had 2 that were series. They get all the current. We circle them, that one and that one. If they get all the current, their I has to be 0.092. So current I1 has to be all the current, 0.092. And resistor 4 gets all the current, 0.092. Alright. Okay, as soon as you know 2 things, you're going to immediately solve for the third. So I know the I know the R. To solve for the delta V, remember I'm just using my delta V equals I times R. I now, for the first resistor, I have R, so 0.092, multiplied it by my resistance of 200. If I multiply these two numbers by each other, I get about 18.4. These, all the I's are amps, all the voltages are volts, so I'm not gonna label them all. I'm gonna do the same thing up here. This time it's delta V4 equals I4 times R4. I still know the current, it's 0.092, but this time the resistance is 100. So if I multiply those by each other, I get 9.2 volts, so delta V4 is 9.2. All right, I taught you how to do this yesterday to make the jump. So we had to start with our series resistors. To make the jump to parallel, you have to follow a path. So I'm going to follow the green path. I have to know how many resistors I go through. I go through resistor 1, the resistor 2, and resistor 4 before those electrons get back to the beginning. Okay, one of the rules of electricity, when the electrons leave with a voltage, in this case 40 volts, by the time they make their way around a loop, they lose all of their voltage. They use it up to push through the resistors. Okay, so I've got 40 volts in order to start. I go through this resistor, and this resistor. So in order to just kind of figure that out, I know that delta V1, the voltage here, delta V1, plus the voltage here, delta V2, plus the voltage here, delta V4, has to add up to the total voltage of the battery, which is 40. Well, I already know two of these numbers. I know that delta V1 is 18.4. I don't know delta V2 currently, I haven't found it yet, but I do know delta V4 is 9.2. This voltage plus this voltage plus this voltage has to add up to 40. I know two of the voltages. If I subtract away, I find that the leftover voltage is 12 point, oops, sorry, put it in the wrong spot, is 12.4. All right, as soon as I know that voltage, I can use my delta V equals I times R to find the current right there. I'm going to leave you to do that. And then if I want to follow the pink path in order to go to this direction right here, I'm going to follow the same idea except I'm going to follow pink. So as I go through resistors, I go through resistor 1, resistor 3, and resistor 4. Voltage plus the voltage has to add up to the 40. So delta V1 plus the third one, delta V3 plus delta V4 has to add up to 40 on my pink loop. I still know two of them. 18.4 is delta V1, 9.2 is delta V4. When I subtract, I'm going to get the same number. My delta V3 has to be 12.4. Notice these are parallel. They should have the same voltage to each other. Okay, series has the same current, all the current. Parallel gets the same voltage as each other. And once you have that, you are able to find the current for that. Okay, so that's number 8. So you have a little bit to finish off with that. As you look at number 9, I just want to make sure I'm going to turn you loose. If you're unsure, you're going to just recap that last portion for number 8. It's the same exact thing. I just want to make sure that you know what ones are series and which ones are parallel. Okay, so once again, I'm going to start at the battery. It's down here this time. I find the negative. I'm going to start in pink. I can go that way. My electrons can go that way. And my electrons can go, what's another good color? That way. There are 3 paths that they can follow. Okay, what we have to figure out is what is a series and what is parallel. Okay, so reminder, series means it gets all the current, all 3 colors. So as you look at resistor 1, it gets all 3 colors. That makes it a series resistor. Resistor 2 only gets pink through it. Resistor 3 only gets blue. Resistor 4 only gets red. But then as all the current comes back through, notice there's no route back to the battery except to go through resistor 5. Resistor 5 is a series resistor. It gets all of the current. Right? So I have 2 series resistors, which means I add them in normally, and I have 3 parallel, which means it's not to this shape. It just means they only get partial current. Okay, so as you're starting to find the REQ, the first ones you have to do the parallel first. So you have to go 1 over 550 plus 1 over 1000 plus 1 over 1340. Okay, 1 over plus 1 over plus 1 over. You're going to get a super small decimal. That's not your REQ. 1 divided by that decimal is going to give you the total for that. And if you do your math correctly, when I flipped it off the bottom, I got 280.5. That is not my total resistance. That is the resistance of the parallel ones. To that number, I have to add the 445 and the 800, the series ones. Okay, so you have to add in the parallel first, get a total answer, and to that you add in the series ones normally. That will give you your REQ. Then, to find the total current, you take delta V equals I times R. We know the voltage of the battery is 120 volts. You solve for I with whatever resistance that you just got for REQ. Okay, next steps, get them labeled. I2, delta V2, I3, delta V3, and I'm going to scrunch the 4th one, I4, delta V4. Okay, you have to start with what gets all the current. The 2 series resistors get all the current. So whatever your total current is, that is going to be the same as I1 and I5. They are going to get the total current. You'll be able to then multiply to find the voltages. And then just like in problem 8, to make the jump, once you have your voltages, you follow a loop. If you follow the pink loop, all the voltages have to add up to the total of the battery. So if you're on the pink loop, you go through resistor 1, so delta V1. You go through resistor 2, so delta V2. And you go through resistor 5, delta V5. Those have to add up to the total voltage of the battery, which is 120. All right, you'll find 1 and 5 and subtract from 20. That will give you the voltage for resistor 2. You then either, because they're parallel, all their voltages are the same, or you repeat that process except for the blue loop and then for the red loop. All right, once you know the voltages, you can solve for the current. All right, I hope this helps get you through the last 2 problems in the packet. I'll be available for questions in class 2. Thank you.